So we have a 10-sided pyramid, which I'm not really going to draw, but just imagine that this has 10 sides. That's too thick. With a height of 14. So the height goes from the center down to the middle. We know this is 14. We know the volume. We want to figure out what the side length is. Okay, so we start with our formula for volume of a pyramid. 1/3 the area of the base times the height. So that's the volume formula for any pyramid. So we know the volume is 323, point all these decimals, equals 1/3 the area of the base times 14. So we have to determine, how are we going to find the area of the base? Which formula are we going to use? Well, it turns out there's a pretty handy trig formula with just the base in mind. And that is n times the side length squared over 4 times the tangent of the trig angle. Where the angle in this case is 360 divided by 2 times 10, 2 times the number of sides, which is 18 degrees. So that's the formula that I'm going to put in here for the area of my base. 10 is the number of sides. I called my side length x over 4 times the tangent of 18. Times the height of 14 equals this volume. So all we have to do is solve this for x. So simplifying the right side, I have 10 times 14, which is 140x squared in the numerator. And in the denominator, I have 3 times 4, which is 12, times the tangent of 18. And that's supposed to equal this volume. So we're going to multiply everything by this entire denominator, 12 tangents of 18, on both sides. Okay, that gives me 140x squared. All this is 1260. Like I said, 1260. Then we're going to divide both sides by 140, and I'm quickly running out of room, so let me make some. By erasing my drawing. So I'm going to divide both sides by 140. And 1260 divided by 140 equals 9. Okay, divide by 140. And then square rooting both sides gives me a side length of 3. So my decagonal pyramid with a height of 14 has a side length of 3 to give it that volume right there. Okay, so let's talk about the next one. The pyramid from before is melted down and reformed into a cube. Okay, so we had some type of a pyramid here. That's a pyramid. And it got melted down and turned into a cube. So we're assuming that all of the material, maybe it was made of plastic or even wax, maybe it was a wax candle or something, and it got melted down and formed into a cube. So the thing that stays the same is the volume. The volume of the cube is the same as the volume of the pyramid. Okay, so if we go back, we find that the volume was 323 points. Actually, let's go back. 1567714. Now that's turning into a cube, so the volume formula for a cube is x cubed, because all the sides of a cube are the same. So to solve this, we simply need to cube root both sides. And that tells you what the side length of your cube is. And my calculator says that is 6.86. I believe the units were centimeters. So when shapes are changed into other shapes, their volumes stay the exact same. Okay, the shape changes, but the amount of material doesn't. So it's important to remember we are conserving the volume. Nothing is lost anywhere else. Not like when you chop a tree down, you have wood splinters everywhere. So let's say that that cube is melted down and reformed into a hemisphere. Because one shape is boring, so we have multiple shapes. So we take this cube, this Play-Doh cube, let's say it's Play-Doh, and we reshape it into a hemisphere. We want to know what the diameter is, so all the way across. But still, the thing that stays the same is the volume. So even when objects change shape, the amount of material stays the same, and the amount of material is the volume. So once again, our volume was 323.15677714. And now we have a hemisphere. The volume formula for a hemisphere is 2 pi r cubed divided by 3. So now we have to do the algebra to solve this equation for r. So the algebra says multiply by your denominator. Is 969.4703 2 pi r cubed. Okay, next we'll divide by 2 pi, and when you put this in your calculator, make sure that you parenthesize it, or you're going to get the wrong answer and your calculator will be confused. That gives me 154.29599. And the last step is to cube root both sides. Which gives me a radius of 5.36. So if that's my radius, then the diameter is 10.72 centimeters. So whenever we have a problem where something is changing shape, remember that the volume stays the same. So we need to figure out the volume formula for every given problem.